All right, well, these 6s are getting too redundant. This one has bad capacitors also. I guess that's to be expected, but I found a lot of ripple on the 5-volt supply, which are these two big guys here. These are 2,000 microfarads, so it's 4,000 total. And while I'm in there, I might as well change this one, which is for the plus and minus 16. So went to the store, and let's see, what did I get? I got these guys. That one for them, and then I thought these would look. She offered me 2 different versions. One was just a regular black one, but I like these. They say made in West Germany. So yeah, if it says West Germany, you know that it's pretty old too. But I thought, what the hey? I think it'll be fun to put in. We better test these before we put them in, because they're vintage too. But I thought they matched the unit, and they would be a good substitute in. So they are measuring overload. Oh yeah, these are 2,000. This won't go to 2,000, but I can't test the ESR. Yeah, 0.09. Yeah, that's pretty good. Just for grins, what do these guys measure? Let's see here. Let's turn off ESR. 1,500. Yeah, they're a little sick, maybe. I don't know. Anyway, they had a lot of ripple on the picture, so that's what counts. That's what counts. All right, let's see if we can't. That hole isn't big enough. Oops. Single-sided. This is a cool single-sided board, and it's copper on the back. It looks like you could make these at home, except for the silk screen. So they're kind of fun. They're kind of fun. All right. Bend these. Let's make this one. Just eyeball them. It's fine. I bought a couple other things while I was at the store. I thought they'd make good videos. I always look around the place. There's a lot more there than you think. So. Oops. Something went on the ground. That's okay. This is plus. Oh, I know what it was. It was there was a little standoff here with a hex nut. That's what fell off. I have to find the hex nut on the floor. Okay, let's get these soldered down. Uh-oh. That one's sticking way up out of the air. Let's get that one back in there. There we go. Wow. I don't know how that happened. Thought I'd bent it over. All right. There. I'm not quite sure where they got these connector system here. I've never seen it before. But it is nice it's all in connector so you can lift things out, work on them, put them back in. So you can just pop this right back in. Pretty nice. Alright, I need to find that 440 hex nut. It's on the ground here somewhere. After you've dropped as many things as I have, they all seem to go into the same spot. So I know where to look. Oh, shoot. Oh, man. I dropped it way down in there. Oop. Come on. Oh, come on. Jeez. Give me a break. All right, all right. Wow. Oh, my goodness. You know, one of those days, it seems like you're dropping everything. I don't know what the deal is. I accidentally drank some energy drink last night. I thought it was like a Kool-Aid type of thing, but it had a lot of caffeine in it. So I was quite chatty with my wife. I had lots to say. Okay. There we go. Now we can put this on. And we can put this on. And we can spin that on. There we go. Perfect. Okay. Let's throw these away. And put this on its side so we can get to the power supply. It's easy to probe it from the bottom. Here we go. There's the ground. And 5 volts was that one there. Let me plug in the device. And we'll turn it on. And it looks awful still. Uh-oh. What is going on? Can you see that? No. Can you see that? Yes. That does not look good. That does not look good. All right. What is going on? What is going on? I thought it was just a capacitor issue. Those are... Wow. 1, 2, 3, 4, J5, 6. Yeah. 1, 2, 3. So this is 16 volts. And this is the minus 16 volts. There's a 100 volt. And then there's the 8 volts. Should be 8.8 volts. And it's got a huge amount of ripple on it. Wow. Wow. I wonder if the bridge is dead. I checked the diodes on the bridge and they seem to be fine, but we could... I don't know what the problem is. 5 volts. Yeah, let's look at one of the 5 volt lines, because that's how I noticed it at first. 5 volts. 5 volts, let's see. I can look at this pin. Let's see here. Yeah, let me back you out. All right, we are looking here. This is the card. This is the master oscillator card, and pin 2 is 5 volts. Pin 2, which is this one, I believe. Yeah. See that? It's trying to be 5 volts, but it's drooping down because that first section has too much ripple on it. We're getting 5 volts most of the time, but not all of the time. That's not good. It's possible. What's possible? Like I said, maybe the diodes are only rectifying in part of the cycle. I don't know. Let's turn this off. And once again, I'll take this card out. Come on. There we go. So, yeah, let you look at the card. So these are the ones I just replaced, and I replaced that one there. Did I put it in the right way? Yeah. So here are the diodes, individual diodes, and I did measure all of them, and they did seem to be okay, but one never knows, does one? Let's measure them again. I'll use a different meter. Right. Let's see here. How about this one? 0.4, 0.4, 0.4. Oops. Okay. Are these even hot? Oh, oh, one of them's kind of hot. Ah, that guy's kind of hot. Let me do them the other way. See if they're all. Oh, that one kind of. That might just be voltage in the system, but that diode is a little warmer than the others. Let me put it back in. I'll use my thermal camera. Maybe one of those diodes is just sick. Sick. All right, let's turn on the thing. Yes. And we'll watch those. Ooh, 2 of those diodes are getting hot right away. Yeah. 2 of the diodes are very toasty. That's interesting. Can you see that? Yeah, you can see that. Why are 2 of the diodes toasty? It is a full bridge rectifier. It should have equal current in all four, unless that's not the 5 volt section. Let's see. D307, yeah, that's the 5 volt section. 308, 307, 8, 9, and 10. 307, 8, 9, yeah. Maybe we should just replace those diodes and be done with it. Or pull them out of circuit and test them. Hey, I have a curve tracer. Maybe we could try them on my curve tracer. All right. All right, I want to show you something. Is that going to focus? Let me put it down so I'm not holding it. That might focus on it better. Yeah, there we go. These two diodes, I believe, are getting hot, and these are staying cold. And these two diodes are of a different type than these two diodes. These two diodes match. Those two diodes are different. They are not the same part number. And I'm wondering if something happened and they replaced it with a wrong, they maybe put a weird zener in there or something. I don't know, but it's unusual that they don't match. So I think they need to come out. Yeah, I think they need to come out. All right, we have some some diodes. Some diodes that we can test. Let's try out our TC1. Oops. Let's see, these two diodes match, so we'll test those two. Oops. Diode. Okay, those look fine. Let's try these guys out. Diode. Okay. Diode. Okay. Well, they test okay here, so maybe we could put them on the curve tracer. All right, curve tracer. This is the VF curve of the diode, and we are on 0.1, so 1, 2, 3, 4, 5, 6, 7, 0.7 volts at so many milliamps to 2, 4, 6, 8, 10, 12, 14, 16, 18 milliamps. So yeah, that's fine. That's doing fine. All right, and then the other thing that we can do is test any breakdown. And so I'm going to go to AC mode, and we can lower this one down. So AC mode, we can, oops, let me jiggle this knob, there we go. AC mode, we can go to 0, 0, and I can go to 75 volts and go up halfway. And I don't see any breakdown. So yeah, there's no breakdown. And I've tested all four, and all four match. So I don't know, there's something else going on. But I got to use my curve tracer for a real project. Woohoo! Huh. Well, I guess I'll just put them back in since they test out just fine and try to figure out what else might be going on. What else could possibly be going on? All right, so I soldered those diodes back into the board. They were fine. When I was soldering them back in, I found it a very difficult soldering job. The solder was not wicking to the actual diode itself. I had to add a lot of heat. I had to use a lot of flux, and I finally got it to meld. And so that could be it. Like I said, you have to know the people's skill level to put these things together. So if I turn it on now, you can see that it's better. I wouldn't say it's great, but I would say it's acceptable because it only has to be 8 volts. And I think this is something right around 8 volts with some ripple on it. It's peaking at 10. So it may be better now. it may be better. So let's go look at 5 volts. And yeah, see, look, 5 volts is solid now. Good deal. So I think it was just bad soldering. So only 2 of the diodes were working and the other 2 were not working. And that caused too much droop and yada, yada, yada. So yeah, we've fixed all of that. Maybe the capacitors were fine, but they have new ones now. And we have a good 5 volts, solid 5 volts now. So I think we are better. We are better. I don't know if it'll work, but we are better. Let's see what it does on the front panel. Oop. And, oh, the gate light's flashing. That's interesting. I don't think that flashed before. So let me show you what's going on here. I don't think we saw a gate light flash before. So we are gating. Let me turn up the voltage a bit. Let's see here. Frequency, we're at 1 kilohertz. Sine wave, amplitude, let's do 1 volt peak to peak. And we are gating, but still no picture. Let's go ahead and give it 5 volts just for fun, or 2 volts or something like that. And a number of 3 volts peak to peak. Is it doing anything? No. But it is gating, so that's encouraging. And now we have a solid 5 volts. Let's probe one of the ICs and see if we're getting 5 volts on an IC. Let's see here, pin 14. Yeah, 5 volts. We're getting kind of low. Let's see here, measure, add vertical volts, average. Okay. Let's see here. 5 volts is here. 74. Shoot. Everything's in the way. I'm not getting 5 volts. What's happening? What's happening? Maybe that's a clue. I'm not getting 5 volts. I was on that other board. Let's go back underneath. So there are 2 voltage regulators. And it's possible that one works and one doesn't work. So let's go back and look at that board again. That one has 5 volts. And 1 5 volt source to time base and counter, 5 volts to input circuitry. 5 volts to input circuitry. So input circuitry is the other board. And the other board, 5 volts, is on pin 4. Pin 4. That doesn't look right. 1, 2. That's minus 16. It's on pin 2. Pin 6. Pin ground. I'm confused now. 1, 2, 3. 1, 2, 3. 1, 2, 3, 4 should be 5 volts. And it's not even wired up. J5 is minus 16. That's not wired up either. Maybe it's counting backwards. 1, 2, 3, 4, 5. Something's not right. Something is not right. Let's see, here's here's 5 volts, and there's 5 volts. And the input section Yeah, 5 volts. Well, I'm not sure if it was ever wired correctly. That's the input board. And pin 4 should be 5 volts, pin 5 should be minus 16, and pin 6 should be plus 16. 1, 2, 3, 4. 1, 2, 4, 5, 6. 4, 5, 6. There's no wires on 4, 5, and 6. Maybe this thing was never built right. So there's 3 empty pins here. And I believe there's supposed to be power on those pins. So yeah, let's look a little bit deeper on that one. All right, I'm sure this video is way, way, way too long. I was just counting pins wrong. So this pin here is 15.7 volts. And this one is minus 16.7 volts. And this one is 4.6 volts. So that's the 5 volt line. So plus minus 16 of 5, and they don't have any ripple on them, and they look reasonable. A little bit low, but they look reasonable. I pulled that card out so it wasn't loading down anything, and the power comes into this section here. There were some very toasty parts. They were warm, but back in the day everything was warm. So reasonable soldering, you know, probably didn't have a great soldering iron, but they did a reasonable job. So anyway, yeah, more to come.